So for question 3, we need to find the equation. The first one, we have the equation. Remember, this is in the parametric form, right? So we want to find the equation of plane in the scalar product form. So remember, we talk about this, that usually the equation of the plane, right, the most useful form is the scalar product form, because we can see the normal, okay, and then we can see the a dot n, right, where is okay. Also after that, right, we want to find the equation of the plane in scalar product form. So you need to, you can draw it out. Okay, basically this looks like a plane where you have the two direction vectors that are parallel to the plane. So if I have a plane, and I mean so-called, they are not lying on the plane, but maybe one of them is a negative 2, 3, 0, the other one is a 0, 1, negative 1, right? What we can do, we can actually take these two vectors, we do cross product, we will get a normal, remember? Right, so if I cross product two of them, I'll get normal. And that's what I'm going to do. I'm going to do first thing, I'm just going to show you how the question look like. Okay, so this is a plane one. Alright, so first want to find a normal. Normal to the plane will just be equals to the cross product of negative 2, 3, 0. Cross product with a 0, 1, negative 1. And that will give me negative 3, negative 2, negative 2. Alright, with that, first one, okay, remember the vector scalar product form for equation of plane is r dot n equals to d. So r dot n is a negative 3, negative 2, negative 2. So some of you actually make careless mistake. You found the vector, you found the normal wrongly. So if you do something like that, please be very aware. Don't make any careless mistake, silly mistakes when you are finding doing cross product of normal vector. You shouldn't be doing it by now. Okay, so always check. R dot n, remember this r dot n equals to a dot n, right? So what is a? A is the position vector of a point that lies on the plane. Okay, as we know, we can take a to be 3, negative 2, 2. Alright, dot product with n. What is n? Negative 3, negative 2, negative 2. Okay, so with that, it's just equals to r dot negative 3, negative 2, negative 2, and negative 9, positive 4, negative 4, you're just going to get equals to 9. Alright, and how about part 2? Okay, part 2, find the acute angle between plane 1 and plane 2. So this is easy, right? A very standard question. So when you want to find, remember we have plane 1 and plane 2, when you find this a standard formula, and it's just cos theta will just be the, first of all, the modulus of the dot product of the two normals. Alright, and this just equals to first one. And second one must be square root 17 and square root 1. Alright, so all goes well, answer, your theta should be equals to 43 degrees. Now if you made a mistake, probably it's because you've either okay, I'm not sure why it could be that you use sine theta instead of cosine, or you took the negative of it. Okay, so this, otherwise you should get this mark quite easily. Okay, part 3, find the vector equation of the line of intersection between plane 1 and plane 2. Right, so this finding the line of intersection between plane 1 and plane 2, is it easy? Actually, is really, right, rather easy, right? Because all you need to do is you can just use the GC. Now this is a question that appeared quite a few times in your tutorial. All you need to do is you can just use the GC, right? So first one, let's look at the plane 1 equation. Plane 1 equation looks like that, right? It's just equals to 3x. We just relate from the scalar product form. This is the first equation. Second one is just x equals to 0, right? This is plane 2. Alright, so all you need to do is just solve using GC. Alright, and very quickly, okay, I'm sure you're able to get an answer. So your line of the intersection is just equals to 0, 9 over 2, 0, plus alpha, 0, negative 1, 1. So I hope you are able, I'm able to show the GC method through this software, but I mean, just key into here, you just key into the GC, right, add polysimal, then 3 unknowns, 2 equation, and then you solve. Alright, next, Okay, 3 part 4. Okay, the plane P3 has the equation x plus ay minus z. Given that the acute angle between P3 and L is 60 degrees. What is L? L is the line of intersection, right? So we need to find the value of A. So quickly, remember that L as we have found in part 3, right? Is none other than 0, 9 over 2, 0, plus alpha, 0, negative 1, 1. Okay? Next one is the plane. Alright, the plane P3. Right, this is none other. Let's say if I write it in the scalar product form, this will just be x r dot 1 r dot 1 a negative 1, right, equals to 0. Alright, and here you just recall that we have studied before angle between a line and a plane. Right, if you talk about line and a plane, this is a sine theta, where m1 is the direction vector of the line, and n. Okay, maybe I don't use n1, Okay, just use m. M is the direction vector of the line, n is the normal of the plane over mod n, like that. Okay, yeah, and with this, right, here the equation of the angle between the line and the plane is 60 degrees, so it's sine 60, right, equals to mod of m1. So what is m? M is the direction vector of the line, 0, negative 1, 1. The normal of the plane, 1a, negative 1. Okay, over the 0 square plus negative 1 square plus 1 square. 1 square plus a square plus negative 1 square. Okay, sine 60 degrees will be equals to square root 3 over 2. Okay, on the top, what are you left with? 0, 1, 0, negative a minus 1. So the modulus of negative a minus 1. What are you left below? Below, you're probably left with square root 2. Alright, on the right hand side, you have 2 plus a square. Okay, and simplifying the denominator, the top actually, okay, just keep it negative a minus 1. This below become 4 plus 2a square, square root 3 over 2. Alright, and simplifying this, you will get square root 3 multiplying with square root 4 plus 2a square. I basically just cross multiply. Okay, 2 equals to 2 modulus negative a minus 1. Okay, this is just a square root of 12 plus 6a square equals to 2. In fact, mod a negative 1 is just actually, I can convert this, right? Negative mod a is just a plus 1, right? Because I can take out the negative sign, doesn't matter. Square both sides. I have 4 a plus 1 square. Once I square, the modular sign is gone. And simplifying this, you get a squared minus 4a plus 4 equals to 0. You get factorize a minus 2 square equals to 0. A equals to 2. Okay, and that's for question 3.